Hello everyone, we are back with another very good question. The name of the question is edit distance. On Leetcode it is medium, but I've seen few sources where it is labeled as hard as well. But if I had to rate it, it is just medium, I would say. But in any scenario, let's jump into the solution quickly. The question is very simple. The reason for that is that the hint is there in the answer itself, in the question itself. So word 1 is to be converted to word 2. Horse is to be converted to Ross or many other words. There are three operations which we can perform. The first operation is either we can insert an element in horse, or we can delete a character from horse, or we can replace a character. So we'll quickly go to the solution. Let's say, or let's not say, let's just have two words over here, horse and Ross. So what we are going to do is we are going to use loop I and loop J, not loop, but the elements I or the index I and J to iterate over these words. So what we are going to do is um, there are three things for converting that are allowed for converting this word to this particular word. The first thing is either to delete an element. So let's say we delete horse, we delete h from horse. So in that scenario, we'll call the solve function with I plus 1 and j remains there. And this, since this is an this is an operation, we increase the number of operations. So basically in the solve function, we have three elements. One is I is I index, the second is J index for the second word, first word, second word, and the number of operations till now. So since we deleted H, we incremented I. Now I will be pointing to O, and we didn't increment J because here we have deleted H and we have not done anything to the second word, so j remains same, and k plus ones 1 for incrementing the number of operations. In the second scenario, what we can do is we can replace this h with r. The reason is that we ultimately want it to convert to the second word, so we'll replace this h with r. In that scenario also, we will increment s because the next element which we want to see is going to be O. So we'll also increment I plus 1, but at the same time, we'll also increment J because anyways, we have made H and R to be same. So there is no point in considering the same element again over here. So we'll also increment J. And since this is a replacement operation, we'll increment K as well. Now there is one more operation that we can do. Let's say instead of doing these things, we just add an r over here. We add an r over here so that again it becomes same as the other element, the element from the other word. So in that scenario, you will see that I doesn't increment because we inserted r before I. Now we'll again have to look at the same element, that is h. So in that scenario, I will remain same. J will increment because the element we wanted to make similar is already made similar. So J will increment and K will also increment. So these are the three cases which are true when we are seeing that I and j elements are not equal. These are the three operations which we are performing. If they are equal, let's say we reach to a scenario where we are comparing ORs and OS. So we see that these two elements are equal. In this scenario, we simply have to increment I and j because we are not performing any operation. They are same, right? So we neither have to delete it, nor we have to insert it, or nor we have to replace any element. So we simply increment I, simply increment j. We don't increment k because we didn't perform any operation. So these are the operations you can see we have performed over here in a recursive when we are trying to solve it recursively. So we see if they are equal, we increment both, and K is not incremented. In the other scenario, we have just performed all these three operations: replace, and delete, and insert. And that's why I said the hints are there in the question itself. But okay, so the next thing is how to end this, the break condition. So the break condition is, let's say either we reach to the end of both the elements at the same, both the words at the same time. That scenario, we processed all the letters here, all the letters here. In that case, we will just simply write answer equals, uh, okay, answer equals min of answer and k. Okay, minimum whatever is there already in answer, or k. But there's a scenario in which we have, let's say, processed four elements from here. E is left, and we have processed all of them, so that's basically E, and the second word has ended. So this is where I is at E, or I is at basically 4, and J has ended to the end. J has J equals to 3. So in that scenario, let's say in that scenario, J, when J has reached 3, so what happens? This means that while converting this to this, we have an extra element left over here. So basically what we'll have to do, we'll have to delete it. So in that scenario, whatever the length of this element, this word is, that is, we are considering it to be M. So we are basically subtracting M minus I, and we are adding this to K. K was the number of operations till now. So basically we have to add one more extra operation for deleting this E, and then again have this equation. So k was, let's say, till now 3. So we want to delete one extra element, so it becomes 4. And now we are checking the same thing, that whether it is the minimum operations till now or not. Let's say we have processed all the elements from horse, but there's one element left in S, and there's nothing left in horse. Okay. So what does this mean? This means J has reached, J has not reached at the end, but I has reached at the end. So I has reached at the end in this scenario. This basically indicates that we have to add an extra element in the first word so as to make this equal to this. In this scenario, we will again add k plus k equals to k plus whatever was the length of this word, that is n minus wherever J is. So that is basically indicating that one letter is left. So let's say this was X, then X plus 1, or let's say it was 2, for example. 2 plus 1 is 3. Now again, we'll run this equation to find, is this the minimum number of operations till now? This is how the recursive solution works, and it perfectly gives the answer, but as per the expectation, it crosses the time limitation. Now, in the other scenario, what we are going to do is we are basically tabulation form, and tabulation solution for this is proved out to be quite easy. I would say it was not that difficult. I will just quickly draw a table for this. So let's say we have 0 or ROS. This is the final word which we want. And then we have HORSE. So from zero elements, if we want to make zero elements, it is simple. We don't have to do anything. From zero elements, if you want to make R, we have to do one operation. From zero element, if we want to make O, we have to do two operation, basically adding R and O. If we want to make three elements, then we have to do three operations. Similarly, for from H, if we want to make zero elements, we have to delete H. From HO, if we want to do it, we have to delete two elements, three elements, four elements, and five elements. Now we'll take two scenarios quickly. So one scenario will be where the letters are equal. So let's say this particular ca- this particular column or this particular cell we are calculating. So that is basically how to make HOR to ROS. Now there are three options. These three are the, well, since R and S are not equal, let's be very sure about this. Basically in this matrix mat and this matrix IJ, when we are calculating, so word one, word word one minus word from word one, if we minus I minus one, like let's say, that means basically we are seeing this element and we are seeing word two j minus 1. So these are not equal. Okay, word to j minus 1, these are not equal. In that scenario, what we have to do, we have three options. We'll see this cell, that how many times it required HO, how many operations is required HO to get converted to RO, or we'll see this cell, like how many operations were required to convert HOR to RO, or we'll see this particular cell, that is how many operations were required to convert HO to ROS. Whatever is the minimum in this, whatever was the minimum in this, we'll just simply add 1 to it. Okay, so this is when they are not equal. So basically minimum of top, left, or diagonal element plus 1, if they are not equal. Why we are doing it? We are doing it, let's say, let's take an example. How do we convert HO to ROS? Following this path. Following this path, what we do is we basically delete H, and we will have to delete H and make it R, and then we add S over here. So that's basically H becomes R, H is replaced by R, O remains same, and we add S. So 2 here. If we are following it via this path, let's say HOR and RO. So that's basically saying that I delete H and, or maybe replace H with R, O remains same, and then we delete R. So, and here we see that if we are doing HO to ROS, so, and HO to ROS, we replace it with R, and that makes it RO, and we have S over here. So, and we want to R, we replaced it with H with R, is there, S we added, so that was basically two operations, and now we also have R, in this. So that's basically deleting S as well. Okay. So deleting, that is basically three operations. So what we did was HO was there, ROS we came via this path, we replaced it to R, we had O over here, that was one operation, we added S, that was two operation, and now there is an extra S, so, or there is an extra R, so we deleted this as well. So that was one more operation, three operations. So that was basically coming from this path. Now if we are trying to come via this path, that was basically HOR being converted to RO. In that scenario, what we did was, let's say we deleted it to R, that was one, replaced it to R, that was one operation. There is O, which is not an operation. We delete this R as well. Okay, so that is one more operation. And now we want to add S. So this is one more operation. So total of three operations. Now there is a way to come via this path as well. So that is basically HO converted to RO was one operation, H converted to R. And now we have S. Now we have R over here and we want to make S. So simply replacing this particular R S. So two operations. So what was the minimum amongst these? So minimum amongst these was adding one to this particular path, right? Having basically H converted to R and then R converted to S. So basically HOR we wanted to convert it to ROS. So this converted to R and this converted to S. So it became ROS. So two operations. So this was this way of telling that what does it mean to select the minimum among these three. Not selecting the, if let's say it was equal, let's say here O and this was equal. Okay, so in that scenario, we directly take the diagonal element. So how we do it? H R, simply one operation was there, converting H to R, that was replacing H with R. And since these two are already same, so we just add plus one in this. So one plus one, that is, we don't even add anything because since they are already same, we don't need to do anything. That is basically one operation. So it will remain one. So all said and done, there are two things. If word 1 I minus 1 equals to word 2 j minus 1, in this scenario, we simply select the, we simply mat ij becomes simply mat I minus 1 j minus 1 if they are not equal. In the else scenario, what we'll do is we'll simply say mat I uh, j. What we'll do is we'll select the minimum of top, diagonal or left, and we'll add 1 to it. The reason for this is explained because we are selecting the different path for forming this particular element or this particular word. In this scenario, there is one more thing actually. If they are equal, so that in that case also, instead of taking the diagonal elements, we can do one thing. We can take from left and right, we can take, let's say, if we go to the previous matrix. Okay, I think I have deleted it. So even in that scenario, what we can do is we can, let's say if we are calculating it for this element, we, instead of taking this diagonal, we can select the minimum from these two and add one. Okay, but that basically is being the same, is we'll see that the minimum from these two adding one is same as having this particular element over here. So yeah, that is, if we calculate it will, if we observe it, it will be same. So we can directly put it or we can keep it that way. So even that's what I have given over here as a solution. You can see, uh, see, it was either taking from the diagonal element or we are taking from the minimum of either taking the left or top and adding one to it, or we are taking the minimum of diagonal element. So in any scenario, you will see that the diagonal element will be the least one. So we can directly put it there as well. So if we, let's say, comment this particular line and we uncomment this particular line, I hope this will work. Yeah, so this also works, that also works. Both the scenario it will work. So yeah, thanks a lot for this. And yeah, this was actually a medium level question. It was easy and I have not forgotten. I'll bring the uh, tabulation method for solving matrix chain multiplication. Wait for it, it will be there soon after this video. I have actually recorded the video. There was that got a little long, so I have just held it off. I'll bring it back. Thanks a lot. Keep learning and please subscribe and like. Thanks a lot.